Welcome back to the second part of our interface challenge. In the first part, I created the mappable interface. Now I'll create a new class in the same package, and I want that to be named building. I'll add the name and type. Usage type is going to be an enum, but I haven't yet created it. I'll do that after creating a constructor using these two fields. I don't need getters or setters. In real life, this class would be the class you really want mapped that already exists in the application you were updating. I'll set up the usage type enum in this file right above the building class definition. Enum usage type with entertainment, government, residential and sports. That's just a few of the usages a building might have. I want this enum because each type of building may have a different colour or marker shape. I still need to make this class implement the mappable interface. I'll add implements mappable here. IntelliJ is telling us there's more work we need to do because of this change. Let me implement those methods. I'm only going to pick the three abstract methods: getLabel, getShape, and getMarker. And that gives me some default implementations, which I need to edit in all cases. Starting with the getLabel method, I want to return name, then a left parentheses, then usage, and a right parentheses. This means the name of the building and what the building's used for, entertainment, government, and so on, and that's what would get printed as the map label. Next, I'll do the shape method. For this, I want to return the enum value geometry.point. Finally, for the getMarker method, I want to set up icons or map markers determined by the building type, both for their colour and for their shape. We can do this pretty easily with an enhanced switch expression and using an enum variable. First, I'll do a return switch and include the variable usage. Remember, usage is the enum type usage type. I'll add the case for each usage type now. Case entertainment. That's what's nice about an enum, we can use the constant value. So here it's entertainment and a switch expression arrow because I want to return a colour, so colour.green, and append that to a space, then add the point marker dot triangle. Case government will get colour.red plus the point marker dot star. Case residential will return the colour.blue and the square point marker. Case sports gets colour.orange and a point marker dot push pin. Lastly, the default will be a colour.blackwidth point marker dot circle. All of that simply returns a string like red star for a government building or blue square for a residential building. So that's our building class done, and it implements a mappable interface. I'll go back to the main method and set up a list of mappable items. Here you can see I'm coding to the interface by using interface types in two different places. First, list is an interface type, so my variable mappables has an interface reference type. Second, I'm using mappable as the list's type parameter and not building in the angle brackets. That means this list can contain anything that's mappable and not just buildings. I'll add a few buildings that are in the city of Sydney. First, I'll do mappables.add, then a new building named Sydney Town Hall with usage type.government. Next one is Sydney Opera House with usage type.entertainment. Lastly, Stadium Australia, which is a sports arena, so usage type.sports. This code demonstrates that we can add building instances to a list that's declared with a type parameter of mappable. If I tried to add any object that didn't implement the mappable interface, I'd get a compiler error. Now I'll add some code to map it. Well, not really, but just imagine that it could map it. In this case, I'm just looping through the list and calling the static method we created on the mappable interface, passing it the current element in the list. I'll run this, see if it all works. And you can see that for every one of the mappable features I created, I've printed out the mapping features from the abstract method, the type, the label, and marker. It's common practice to dump out all attributes about a feature, or as many as are public knowledge, so I want to include the name and the usage attributes, even though these are part of the label. It could be the people using our data to make a map may want to form the label in some other way, so we'll provide that information as well. To do this, I need to go to the building class and override the toJSON method. I want to edit this. Actually, I want to include that call to mappable.super.toJSON in my result, but I also want to include name and usage. I'll remove that semicolon and add a text block, so I'll type plus and 3 double quotes. And here again I can put double quotes around the property field names as well as the specifiers, so name $S, then usage $S, and then that gets chained to formatted and name and usage are passed to that. Let's run the code to see what this looks like. You can see the output, which should be well formed for the type of file we want to produce. Next I'll create the utility line class. I'll set up the utility type enum above the utility line class definition, enum utility type, with the values electrical, fibre optic, gas and water. This enum represents different types of utility lines or pipelines you might want to see mapped out for a town or city. I'll add name and type files to the utility line class. I will generate the constructor for those two fields. I will make this class implement mappable. You probably knew that's not going to compile because of mappable's 3 abstract methods. So picking just those 3 to implement, I'll generate those. And just like I did for building, I'll change the getLabel method on this class first. This is almost exactly what I did for the building. So return name plus the type in parentheses. That returns the name of the utility and the type for the label on the map and for the getShape method. And for a utility, we want to return a line. Now I'll make the marker that's returned to be different for the different utility types. Return switch using type, case electrical switch expression arrow color.red plus a space plus line marker dot dashed, case fibre optic gets color.green space plus a line marker dot dotted. Case gas will return color.orange and line marker.solid, so a solid orange line. Case water, that needs to return color.blue and line marker.solid again. The default return value should be color.black with a line marker.solid. And for now, I want to copy buildings to JSON method. I'll change usage in quotes to utility in quotes, and instead of passing usage to the formatted method, I'll pass type there. And that's all we need for the utility line class. Let's go set a couple of these up in the main method of the main class. I'll create a utility line object by passing College Street and utility type.fiberoptic, adding it to the mappables list. I will do the same thing for the second object, but this time I'll pass Olympic Boulevard and utility type.water as the arguments. Let's run this now. You can see this uses the same mechanism to map lines on a map. This is just a subset of what a JSON file might look like, but it's a pretty good start. If we really had a mapping program, we could generate the file with our entire list of mappable things or features, and it would have enough information to render things we care about on a map. I did not include map coordinates here, but future challenges will include that. I hope you enjoyed this challenge and can see why using an interface can be used to add functionality to many different types of classes. The client code doesn't even have to know details about the types, only that the type is mappable and it can be used like every other mappable type. This challenge exercised many of the features of an interface, abstract methods, default method, static method, and a constant field. This video ends our introduction to both abstract classes and interfaces. Congratulations on completing this important section that sets the stage for the next few that follow. In the next section, I want to start on yet another Java feature called generics, so I'll see you in that next section.